All right, so I'm going to talk about a paper that I had published a couple years ago, actually 2021, I think, um, related to teacher instructional practices and student mathematics achievement.
Mm-hmm.
So the problem we wanted to address was the low mathematics achievement in general for United States students. According to OECD, data from PISA 2012, which at that time was the last cycle that focused on mathematics. OECD reported that the U.S. spends more money per student than all but four of the 34 OECD countries. But the U.S. only ranked 27th in mathematics. There's long been a lot of research involved related to teacher instructional practices and what are the best instructional practices to use in the classroom. So there's a lot of literature out there on it, but certainly there are a lot of other factors that are related to students' mathematics achievement other than just the teacher instructional practices. So we were hoping that our work could maybe help guide the policies and practices. So we looked at two different types of teacher instructional practices. We put them into the two main categories of teacher directed instruction or student centered instruction. In teacher directed instruction, the teacher disseminates information to the students while the students tend to be generally passive. Whereas with student centered instruction, the students are regarded as more active participants who are working to construct their own knowledge through exploration and reasoning. And there, the teacher's primary responsibility is just to help guide the students by asking thought-provoking questions and encouraging discussions. Um, in the um, in the case of the teacher-directed instruction, if you went into the classroom where the teacher's primarily using teacher-directed instruction, you would observe a small number of teacher-to-student interactions, and you would quite possibly not see any student-to-student interactions at all. Whereas those things are more of the norm when it comes to student-centered instructional practices. And I'll just say TDI and SCI from now on. But with TDI, the focus is generally more on procedural understanding. Just can the students understand the procedures? Can they go through the procedures? Can they get the right answers? Whereas SCI is more focused on developing a conceptual understanding. Do the students understand the concepts? Do they really know what they're doing? Can they explain what they're doing? The TDI tends to focus more on performance. You know, which student is the best in the class? Which student's the worst? Can we rank the students? Whereas SCI tends to focus more on mastery, just individual students. Are they mastering the concepts? Are they making progress toward mastering the concepts? And just because most of the time we can put a particular practice as being either teacher directed or student centered, that doesn't mean for a given teacher that teacher is going to fit nicely into one of those two categories. It's very common that, you know, the same teacher might use a lot of teacher directed practices and at the same time also use student centered practices. But generally speaking, students really need both. You know, to excel in mathematics anyway, that they need to have a firm grasp on the basic skills and the procedures, but they also need to have a conceptual understanding of the content. So the research questions that we wanted to address were as follows. First of all, are the teacher instructional practices associated with student mathematics achievement? And we controlled for certain school and student background characteristics that I'll talk about in a little while. And then if we have a significant association there, we wanted to know, does that association vary from school to school? And then if it does in fact vary from school to school, we wanted to examine whether two school level variables, teacher education and class size, whether they help contribute to the variation in math achievement. So we used data again from PISA 2012. For the US data, there were 240 randomly selected schools, and within those, 7,429 randomly selected students. If you're not familiar with PISA, the students take standardized assessments in the subject areas, but they also fill out questionnaires to get some background information. Not only do the students fill out questionnaires, but the school, people at the school, principals, and so forth fill out questionnaires as well. So the key variables that we looked at in our study, the dependent variable, of course, was the student mathematics achievement. And then student level independent variables were the TDI and the SCI. And as I mentioned earlier, the school level independent variables were teacher education and class size. And then at the student level, we controlled for sex as well as socioeconomic status. And then at the school level, we controlled for the school mean SES and whether the school was public or private. PISA actually had some questions within the questionnaires that enabled us to develop the teacher-directed instruction variable and the student-centered instruction variable. And just as an example, for the teacher-directed instruction, one item on the PISA questionnaire asks students, how often does your mathematics teacher set goals for the students, as opposed to having the students set their own goals? And then in the student-centered questions, for example, one item asks students how often their mathematics teacher has the students work in small groups to solve problems. And so the students had to, for all those, they had to choose, whether it happened every lesson or most lessons or some lessons or hardly ever or never. We did check the internal consistency for the two variables, Cronbach's alpha, and both of them had relatively decent numbers for the internal consistency. Teacher education, you might be wondering what that means. It's the proportion of the way PISA measured it. It was the proportion of mathematics teachers that held at least a bachelor's degree in mathematics or a related discipline. So we are talking about generally high school students here. So it would be nice if the teachers had at least a bachelor's degree in mathematics. Just quickly running through some of the descriptive stats. You can kind of look at those there yourself. I don't want to spend too much time on those since our time is passing by. But because of the multi-level structure of the data, with the students being nested within schools, we used hierarchical linear modeling in order to analyze the data. Specifically, we used a two-level HLM. So we had the student level data as well as the school level data. And we built the model in three stages. First, the null model. That enabled us to estimate the grand mean for student mathematics achievement, as well as partition the variance to figure out how much of the variance is attributable to the students versus how much of the variance is attributable to the schools. At the second stage, we added the student level and school level variables of interest. That enabled us to address the first research question by looking at the effects of the instructional practices. And the instructional practices were treated as random variables at the school level so that we could see whether those effects were varying significantly across schools, addressing the second research question. And then finally, we added the other school level variables to the model to see how much they contributed to the variance. So Significantly, we found that about 3/4 of the variance was attributable to students, but about 1/4 of the variance was attributable to the schools. So the schools are definitely, school differences are making a difference in students' performance. It's not all attributable just to the student differences. Um, Principal findings, we found a 1-point increase in the TDI score was associated with roughly a 9-point increase in math achievement. A 1-point increase in student-centered instruction was associated with a 25-point decrease um, in math achievement. So it was really counterintuitive um, for what we expected to find, I guess. Um, I kind of expected the student-centered instruction
Hmm.
to also result in an increase, but that is not at all what the PISA data revealed. It unveiled, almost 3 times as much decrease as what we saw in the increase with the teacher-directed instruction, and both of those effects varied significantly across schools. Um, so, because those effects varied significantly across schools, we wanted to see, what are some of the school level variables that might be contributing. So again, we checked the teacher education level and the class size, but neither of those um, were found to have any significant effect on the variation. So those were the principal findings from the study. In terms of contributing to the research literature, it just provides more evidence that teacher instructional practices matter, that they're important, that they're associated with student mathematics achievement. Unlike most of the studies that we found at the time that dealt with these, most of them did not employ multi-level modeling, so they were not able to account for the school level factors like we were. And then also a lot of the current research at that time generally used small samples, focused on a very specific geographic region, maybe just a few schools. Some of the samples were not random in any way. And so using the PISA data, we were able to employ a large nationally representative random sample. In terms of limitations, PISA only involves 15-year-olds. So that's something to think about as far as generalization goes. And then also the teacher instructional practices and the math achievement, they were all all measured in a very specific way. So there are other ways, of course, that we could have measured those variables that might have, led to different conclusions. In particular, with the teacher instructional practices, the way those are measured or reported, you might have people completing questionnaires, which is what happens with PISA. But in other cases, teacher instructional practices might be measured based on an outside person doing an observation in the classroom and measuring that. Or you might do an interview with a teacher, and so the teacher might be, kind of self-reporting that way. So there's a lot of different ways. Even the curriculum at the school could have an effect on the type of instructional practices that the students are using. Um, and there is evidence though that even if teachers are using the same curriculum, they may still have very different instructional practices, even though they're using the same curriculum. Um, so thinking in terms of future research, um, it would be good to measure the instructional practices in other ways, maybe multiple ways in the same study, to see if the results are consistent across the various measures. Um, could control for more variables at the two levels. We were restricted to the variables that PISA had to offer. Um, but I think generally speaking, I think it's just important to strike the right balance. And I'm sure you all can all attest to that if you've been in the classroom very long at all. I think it's dangerous to swing the pendulum too far in either direction. To get, too teacher directed I think is going to cause issues, or to get too student centered can cause issues. So just striking the balance, I think, is key.
Okay. Thank you.